Very good day to Megan, Farah, and friends. Today, our group will be present on the topic on industrialized building system and the future of smart construction in Malaysia. Before I begin my presentation, I will introduce myself. My name is ANDDERTON and So the introduction for the IBS is what is IBS and how it is implemented. So IBS is a industrialized building system where a model construction method using building components that are manufactured in factories instead constructed manually on site. This is to ensure higher accuracy, better control of material quality, and faster project delivery. The components involved are likely just as precast walls, beams, columns, staircases, and any other modular unit that are used to be produced using machinery and more in the factory, which is to reduce the human error and allow mass production. Next is how is it implemented? First of all, during the design and planning stage, uh, designers plan the building using IBS friendly layout and standardize all the component sizes. IBS is often used to prepare detailed drawings and avoid design clashes. Next is the factory manufacturing, where the components are produced in controlled environment using both automation or semi-automation, which is the machinery. This is to ensure consistent dimension, strength, and finishing. Next is the transportation to site, where the IPS components is delivered on a schedule using any transportation vehicle to avoid storage issue and damages. Next is the on-site assembly, where using cranes and train installers assemble the components like a building puzzle where the ABS is already constructed at the factory and just placed on site. This is to ensure the construction became faster, cleaner, and safer because there is minimal works to be done on site. Last is the quality check and connection works, where the components are connected using bolts, welding, grout, or precast joints to make the final alignment and inspection, ensure that the building meets structural and safety requirements. Next is why Malaysia is promoting IBS current adoption in the construction sector. Okay, first, why IBS is implemented in Malaysia? Because one is to reduce the dependency on foreign workers, where Malaysia faces a shortage of skilled local workers and only relies on foreign laborers. Uh, so the IBS reduces labor needs because more work is done by machineries in the factory. Next, second, improve productivity and minimizes delays. Traditional construction is slow due to weather, labor issues, and any variation during the construction process. So IBS offers timeless because the factory produces more faster and less affected by external factors. Third is the enhanced construction quality. IBS is a factory-made components where they achieve better strength, finishing, and precision. This reduces the reworks, defects, and long-term maintenance costs. Fourth is the increased safety on construction site. Of course, IBS uses less work on site when they only to be jointed using bolting or welding. Lastly is to support the sustainable and green construction practices in Malaysia. IBS minimizes the wastage, reduces site pollution, and promotes more efficient use of materials aligning with Malaysia's sustainability goals and the GPI, which is the Green Building Index.
My name is Jerry James. Next, I will continue for type of IBS. There are several main types of IBS used in Malaysia. The first is precast concrete, where walls, beams, and slabs are made in factory and assembled on site. Second is steel and metal framing, which is lightweight and easy to install. Third, we have formwork system like aluminium or tunnel form, which speed up the traditional concrete work. Lastly, modular or panel system, where room size, unit, or wall panel are prefabricated and assembled quickly. These different types allow IBS to flexible for various building needs. Let's continue for the benefit of IBS. IBS bring many advantages to the construction process. Firstly, it's reduced construction time because most of the work happen in the factory. Secondly, it's improved quality since components are produced using precise modules and machinery. Other benefit is a cleaner and safer site as there is less material waste and fewer workers needed. In the long run, IBS can also save costs through better productivity and reduce rework. Although IBS offer many benefits, there are also challenges. One major issue is the high initial investment needed for machine, molds, and factory setup. Other challenges is the need for skilled workers who understand IBS technology. Transporting large components from the factory to the site can also be difficult and costly. Lastly, some contractors still prefer traditional construction methods and are hesitant to adopt IBS.
Next, I will present on the introduction to smart construction technologies. The first smart technologies is BIM, which stands for Building Information Modeling, where it is a digital representation of physical and functional characteristics. It creates a 3D model that contains detailed information on material dimensions, structure, MEP system, cost estimate schedules, and maintenance data. BIM allow all project stakeholders, such as the architects, engineers, contractors, QS clients, to work on one shared model, reducing the miscommunication and major errors. Uh, the function of BIM, it supports price reduction where it can finding the design conflicts before the construction begins. Uh, it has a cost estimation, which is the 5D, schedule of planning, the 4D, and facility management, which is the 6D. Next, IoT, Internet of Things. IoT are smart devices based on construction sites, machinery, or buildings to collect real-time data. The IoT has sensors that can detect temperature, humidity, vibration, and structural movement. The reason the uses of IoT is um, to ensure safety through real-time alerts. Second is to make a better quality control way. For example, monitoring concrete curing conditions. IoT also can produce a predictive maintenance to prevent equipment breakdown. Next is the robotics and automation. These are used to perform repetitive, dangerous, or labor-intensive tasks faster and more accurately. For example, robotics reduces the reliance on manual labor and enhance safety by keeping workers away from hazards. The automation also improves speed, consistency, and cost effectiveness, especially in IBS factories where robotic arm handle molding, curing, and finishing, which also supposed to push the Malaysia to reduce the foreign labor dependence. Lastly is the drones and AI application. For the drones, UAV are used in construction for aerial surveying where they are monitoring from above the sky. It also helps to make progress tracking, mapping, and inspection. For AI, it analyzes the drone data after collecting all the data from the sky or monitoring the construction progress. AI also has the bin models and MOT readings. The AI also helps the automation on detecting hazards, cracks, or unfinished works. AI also helps to produce a tracking and a schedule forecasting for the construction project. It also can do a site progress comparison with BIM, and then AI also has a safety monitoring through video analytics.
So I'm going to be explaining about the integration of IBS with smart construction. So everything starts with a digital workflow. We design the building on the computer, then the design data goes straight to the factory, from manufacturing, and finally to the installation on site with the tools like BIM, building informations modeling. All stages are connected smoothly, which help with automated fabrication planning and makes installation more organized. In smart IBS factories, machines such as CNC automation system and robotic have produced components quickly and accurately. AI system also check the quality to make sure that every part meets the requirement standards. On site, we use IoT can sensor to monitor real-time progress. This sensor can track installation, give predictive maintenance alerts, and send live data to dashboards so the teams always knows what's happening. By combining IBS with these smart technologies, we get better accuracy and efficiency, less rework, higher precision, and a faster assembly with very little waste. In the end, smart IBS makes construction more efficient, reliable, and modern. So for the future of smart construction in Malaysia, we will see more modular construction supported by system like IBS. This means faster project timelines, better quality, and less on-site labor and waste. So Malaysia is also moving towards sustainable and low carbon building methods by using eco-friendly materials and energy efficient designs to reduce the overall carbon footprint. The government digitalization efforts supported by centers such as My Beam Center, which encourage more companies to adopt smart and digital methods. In the long term, we may even see fully automated constructions where robotic assist assembly and AI planning system guide real-time decisions. Smart construction will make Malaysia's building industry faster, greener, and more efficient. So for the conclusion, the integration of IBS with smart construction technologies is accelerating Malaysia's transition toward a more efficient, sustainable, and high precision construction industry. Through modular methods, digital workflows, and IoT-enabled monitoring, IBS enhance productivity while reducing waste and environment impact. With strong government support and increasing adoptions of automations, robotic, and AI, Malaysia is well positioned to achieve a fully digital and future-ready construction ecosystem. Together, IBS and smart construction form the foundation for a faster, cleaner, and more innovative built environment.